The Curiosity rover, NASA's fourth robot to successfully land on Mars, was celebrated 10 years ago by engineers at the Jet Propulsion Laboratory. The Curiosity rover, which is now old enough to start 5th grade, began its quest to learn whether life may have ever existed on the Red Planet in 2012. The robot, which is about the size of a vehicle, is outfitted with equipment for analyzing the geology and temperature of the planet. How was the mission received? What can the Curiosity rover teach us about space exploration's history and prospective future? Presented by AWZ. Curiosity has traveled from Gale crater to Aeolis Mons over its 10 years of exploring Mars, colloquially called Mount Sharp. The rover has discovered a wealth of information about historical climatic changes, water and geological changes, and other alterations during its explorations. Curiosity is around the size of a small SUV, which is one feature that sets it apart. It measures 3 meters by 2.8 meters, 9 feet 10 inches by 9 feet 1 inch, and is roughly 7 feet high, 2.1 meters. It has a 2,000-pound weight, 900 kilograms. The diameter of Curiosity's wheels is 20 inches, 50.8 centimeters. The rover was created by engineers at NASA's Jet Propulsion Laboratory to roll over objects up to 25 inches, 65 centimeters, high and move around 660 feet, 200 meters, every day. The multi-mission radioisotope thermoelectric generator that powers the rover generates electricity from the heat created by the radioactive decay of plutonium-238. Curiosity has a variety of instruments on board to better analyze the surroundings in support of science. This comprises Mast Camera, Mastcam, Mars Hand Lens Imager, MALI, and Mars Descent Imager are cameras that can capture images of the landscape or of minerals up close, MARDI. Alpha Particle X-ray Spectrometer, APXS, Chemistry and Camera, ChemCam, Chemistry and Mineralogy X-ray Diffraction/X-ray Fluorescence Instrument, CHEMIN, and Sample Analysis at Mars, SAM, Instrument Suite are spectrometers to better describe the composition of minerals on the Martian surface. Scientists use radiation detectors to determine how much radiation is present on the surface in order to determine whether or not humans and bacteria can thrive there. These are the dynamic albedo of neutrons and the radiation assessment detector, RAD, DAN. Environmental sensors to check the weather right now. The Rover Environmental Monitoring Station is shown here, REMS. During the landing, a device known as the Mars Science Laboratory Entry Descent and Landing Instrument, MEDLI, was principally utilized. A few tools are available on the rover to look for habitability. One of these involves blasting the surface with neutrons, which would slow down if they came into contact with hydrogen atoms, one of the components of water. Curiosity's 7-foot arm can collect samples from the surface and roast them inside the rover while sniffing and analyzing the gases that come out to learn more about how the rocks and dirt were produced. If the sample analysis of Mars instrument detects any signs of biological material, it can confirm that. There are many ceramic chunks on Curiosity's front that have been injected with synthetic organic chemicals and are covered in foil. Each of these blocks is drillable by Curiosity, which can then take a sample from each one and analyze it in its oven. Next, scientists will look for organics that shouldn't have been in the block. If so, scientists will probably conclude that these are species that have wandered off Earth. The rover's encircling high-resolution cameras capture images as it moves, providing visual data that may be compared to habitats on Earth. This was applied, for instance, when Curiosity discovered signs of a stream bed. Curiosity reached its science destination, Mount Sharp, Aeolis Mons, in September 2014, not long after a NASA Science Review recommended that the rover focus more on seeking for habitable locations rather than driving. It is presently moving uphill while carefully examining the strata on the slope. The objective is to determine how Mars' climate evolved from wet to arid and acidic conditions. At the time, John Grotzinger, a scientist working on the Curiosity project, remarked during a news conference, "I think the major recommendation of the group is that we drive less and dig more." We are currently at Mount Sharp, so the review's recommendations and what we intend to do as a science team will coincide. The main goal of Curiosity is to ascertain whether or not Mars is or was habitable for life. The rover has a number of equipment on board that can collect data on the environment even if it is not intended to locate life. When the rover transmitted data indicating that Mars had hospitable circumstances, scientists pretty much won the jackpot. Sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon were all found in powder from the initial drill samples that Curiosity collected. These elements are all regarded as building blocks or essential ingredients that could support life. The discovery was intriguing to the mission scientists even though it is not proof of life itself. Michael Meyer, the principal scientist for NASA's Mars exploration program, said that whether Mars could have supported a livable environment is a critical concern for this mission. The answer is yes, based on what we now know. Late 2013 and early 2014 saw a significant increase in methane levels on Mars, reaching a level of roughly 7 parts per billion, compared to the usual 0.3 ppb to 0.8 ppb. This was a significant discovery because methane can sometimes be a sign of microbial life. But it might also be a sign of geological activity. But in 2016, the researchers came to the conclusion that the methane surge was not a seasonal occurrence. However, there are tiny background variations in methane that might be related to the seasons. As reported in December 2014, Curiosity also made the first unambiguous identification of organics on Mars. Although thought to be the fundamental components of life, organics do not necessarily indicate the presence of life because they can also be produced by chemical processes. The discovery, according to NASA at the time, shows that the ancient environment afforded a supply of reduced organic molecules for use as building blocks for life and an energy source for life, despite the fact that the team was unable to draw the conclusion that there was life at Gale crater. Initial findings presented at the Lunar and Planetary Science Conference in 2015 revealed researchers used an unexpected technique to discover complex organic compounds in Martian samples kept aboard the Curiosity rover. Results from Curiosity's research in 2018 provided additional proof that life could exist on Mars. In one study, more organic compounds were found in 3.5 billion-year-old rocks, while in the other, seasonal variations in methane quantities in the atmosphere were demonstrated. There is currently no concrete evidence that the gas is created by live beings, but the seasonal variations may indicate this. Scientists revealed that the rover had discovered some intriguing chemical molecules on the red planet in January 2022. The molecules might represent evidence of past life on Mars, but much more investigation is needed to confirm that theory. There is another word for Curiosity. The Mars Science Laboratory is the official name of the Martian rover known to the majority of people as Curiosity. Because of how lengthy its formal name is, it is frequently referred to just by its common name, Curiosity. Although it should be noted that the mission itself is the Mars Science Laboratory mission, NASA frequently uses both names interchangeably. The power system on Curiosity has outlived its usefulness by a significant margin. There is a radioisotope power system on Curiosity. This type of device uses the heat produced by the radioactive decay of plutonium to produce energy. According to NASA, this power source has operated longer than it should have, which was at least 687 days on Earth or 1 Martian year. Curiosity's design is demonstrated by the 8 years it has spent roaming around on Mars' surface. On Mars, Curiosity captured a 1.8 billion pixel panorama. The 1.8 billion pixel panorama shown in the video below, according to NASA, is the largest and highest definition panorama the rover has ever taken. Even cooler, the panorama revealed some significant findings on the origins of water on Mars. The Mars Science Laboratory mission put a brand new approach to landing to the test. Curiosity's landing on Mars was a significant event. It tested a novel landing mechanism and was the biggest rover to ever touch down on Mars. The new landing technique involved parachute descent of the spacecraft to the surface first, see image to the right, taken by the Mars Reconnaissance Orbiter. The landing mechanism then fired rockets in the last few milliseconds before contact with the planet's surface in order to hover above it as a cable safely lowered Curiosity to the planet's surface. When the link was cut, the landing system took off and crashed into the ground. Wheels down, Curiosity touched down prepared to explore. The revised landing technique worked well. The Mars 2020 Perseverance rover from NASA is based on the Curiosity model. NASA claims that Perseverance, the upcoming Mars 2020 rover, was built based on Curiosity in order to reduce risks and costs. Perseverance will go further than Curiosity by looking for evidence of earlier microbial life. NASA's Mars 2020 rover will try to evaluate both past habitability and look for indications of previous life on the Martian surface. Previous missions have focused on whether there were conditions conducive to life on Mars. Pretty thrilling, huh? Give this video a thumbs up if you liked it and tell your friends about it so we can make more like it. Click the subscribe button to see more content like this, and don't forget to activate the notification bell. Watch our other videos as well if you haven't already. Thank you for viewing.